All right, so if you're dealing with an equation that has a fraction in it, and let's just do some really straightforward, simple ones in the beginning, and then we'll deal with a little bit more complicated ones in a minute. So let's do something like 2/3 x plus 5 equals, let's say, 11. Okay? If you're dealing with this equation, what we're going to say to ourselves is, well, you know what, I really don't like the 3. The 3 is giving me a little heartburn. So what we're going to do is we're going to undo that 3. We're going to get that out of there. Well, the 3 is right now, it's dividing. And what's the opposite of division? Multiplication. So if I use multiplication, I can get rid of that 3. And here's how I do it. You have to multiply everybody by 3. Because remember, all I really care about is getting rid of the 3 that's connected to the x, but I can't just throw that out. If I treat that 3 with multiplication, with that fraction with multiplication, I have to treat everybody with multiplication. I can't just treat one thing. You have to maintain equality. So if I do it to 1, I have to do it to all. So now we have some distributions. Okay. Now, what's happening whenever you multiply a whole number or a constant up against a fraction, that constant multiplies to the top and multiplies to the numerator. It doesn't multiply to both of them. Here's what happens if it multiplies to both of them. This is wrong. If you were to make the mistake of doing this and multiplied it to both, you get 6 over 9, and then that would just reduce back down to 2/3. So in reality, you didn't multiply it at all. Okay? That's why you only multiply it to the top. In reality, it's this. It's 3 times the top, 6 over 3, which is 2. So really what happened is, by multiplying by the denominator, you get rid of the denominator. And that's the whole point. That's why we chose 3 to multiply to everybody, because that's going to get rid of that denominator. So we'll do that. 3 times 2 is 6 over 3. 3 times 5 is 15. And 3 times 11 is 33. Now 6 over 3, we have already done that. 6 divided by 3 is 2. And now it's distribute, move, combine, divide. It's the same thing as we've always done, right? And what's 33 minus 15? 18. Very good. I'm so glad to see everyone's awake this morning. And now we divide. What's 18 divided by 2? 9. And we're done. Okay? So to get rid of that fraction, we multiply by the denominator. Okay? We just got to remember to do it to everybody. Let's do another. Let's do okay. If you want to maybe make your life a little easier, is to get do some of the smaller work first. So you're dealing with smaller numbers. Like if you move that 15 over right now, you wouldn't have to distribute, right? You could just simplify. That might make your life a little simpler. Let's do 10 minus 15. You see, by moving it over, I'm not dealing with 3 things anymore, because 10 minus 15 is very good, negative 5, excellent. So we have and you see now, when you multiply by both sides, what are you going to multiply both sides by? 5, yeah, because you want to get rid of the 1/5, right? Don't forget to do it to both sides. And 5 times 1/5, what does that become? 5 over 5, which is 5 divided by 5. 1. You see, that was the whole point anyway. You know, we multiplied that red 5 onto that to get rid of the 1/5. If it was 1/6, we would multiply it by 6. We multiply it by 10. You see? You want to get rid of that denominator. So now this just falls apart, and this becomes negative 25. And we're done. Okay? Are we cool? Let's do another. All right. So let's get rid of the 3. That's the unpleasant feeling you're having right now. What are we going to do to get rid of that 3? What do you want to multiply by? What do we multiply by? We're trying to get rid of the 3. Multiply by a 3. Well, the right-hand side's easy. That's just 3x, right? Okay. Now, when you distribute that 3, you're going to cancel out that denominator. Does that make sense? Remember, 3 times 2 divided by 3, 6 divided by 3 is 2. And 3 times 4, thank you. And now it's distribute, move, combine, divide. The whole idea of multiplying by the denominator is to get rid of the denominator. And that's what happened. And now we're done. Yeah, you can collect things over on the right-hand side too. All right. Remember, all you want to do is get x all by itself. So you can do it that way. You can do it the other way too. Now, let's try something. How do we feel about this, guys? Horacio? You're all right? Okay, so let's try this. Okay. Actually, can I make this a little easier? Can I just do that one instead? Make the numbers a little smaller to work with. Okay, here we have 2 different denominators. When you have 2 different denominators, you got to get rid of them both. So you would like to multiply a 2 to get rid of the half on the first guy, and you'd like to multiply by 7 to get rid of the 7ths on the second guy. But you can't just pick and choose. You can't just say, oh, I'm going to give you a 2, I'm going to give you a 7, and go on. No, you have to, what you do to one, you have to do to everybody, right? So if I'm going to multiply by 2 to get rid of the first one, I got to do that 2 to everybody. And if I'm going to do that 7, I got to do that 7 to everybody, right? So if we can maybe do that at one time, how do we multiply it by 2 and by 7 at the same time? What would you multiply by instead? Not just 2, not just 7, but both. What would you multiply by? How much? 14. See, 14 is a 2 and a 7 at the same time, right? And by the way, it's not 14 because this guy's a 14, okay? This guy could be anything, okay? All right. So now, here's a way to visualize what's going on. We have 14 times 5 over 2. 14 times 3 over 7. Now, when you multiply that, and 14 times 14 is 196. Okay, what's going on here, even if you did that multiplication out, what's 14 divided by 2? 7. So this just becomes 7 times 5. And what's 14 divided by 2? So I have 35x plus 6x is 196. And you see, by multiplying by 14, we got rid of all of our denominators at once. And now we're just dealing with simple, smaller numbers. Now that's an ugly looking decimal, ugly looking fraction, but we're okay with it because we're done at this point. Okay. One more. Almost done? Okay. Pencil still moving? Okay. Let's do all right. I want to multiply and get rid of everybody. Let's see if we can come up with a number. Thank you. Let's see if we can come up with a number that 2 will divide, 3 will divide, and 4 will divide. Can you think of any number that's divisible by 2, 3, and 4? 12. Because if it's divisible by 4, then 2 is going to go into it as well. Like if you think about all the numbers that are multiples of 4. They're all even, right? You know, if you think about 20, that's divisible by 2. 8 is divisible by 2. 16 is divisible by 2. 40 is divisible by 2. So yeah, multiplying by 12 will knock out the 2, it'll knock out the 3, and it'll knock out the 4. Okay? By the way, we're going to start working on page 23 on that paper, but we're talking about how to do this stuff on page 24, which is on the back. It's page number at the bottom. All right. So let's multiply by both sides by 12. And that's going to kill off all of my denominators and make my life a lot simpler. So 12 divided by 2. 12 divided by 3. 12 divided by 4. 3. Now the 3, once the 12 and the 4 go away and make a 3, like that, I'm going to have 5 times 3, because there's still a 5 in there, right? And can that fraction reduce? Can we reduce that fraction? What would it reduce to? Hmm? 3 over 2. Okay? So the idea is finding a number that'll cancel out everyone. Okay? All right, so I'm going to give you one to do on your own. Let's try this. Let's try So make a decision about what you're going to multiply by in order to get rid of both the 5 and the 2, and then multiply it out. Take a minute. Let's try this. So what's 10 times 2? Any. 10 times 3. 10 times 4. Now, we divide them all. What's 20 divided by 5? How much? 4. 30 divided by 2. See how it's working? This is clicking a little bit. Multiply to the top and then divide. And this isn't going to be a nice whole number, but that's okay. And that doesn't reduce or anything, so we're done. Okay? Does that click? You want to try one more? Yeah? Right under the paper towels. Oh, is everyone finished with that one? Okay. Okay. So now we have to make a decision about how to get rid of the 5 in the denominator on the right and the 3 in the denominator on the left. What number do you want that'll get rid of both 3 and 5? 15, right? Let's multiply everybody by 15. Okay? Now, 15 times 5, right? Well, what's 15 times 10? 15 times 10. 50. 15 times 5? 20. 15 times 5? Well, that's 50. 15 times 10 is 50. 15 times 5 is 25. 50 plus 25 is 75. Come on, you guys. Right? Fifteen times 2. We just did that. How much? Right? And 15 times 2 again? Now we reduce our fractions. 75 divided by 3. You have 75 cents and you break it into 3 pieces. How much do you have? Yeah, you got a quarter, right? $30 divided by 5. And now we move everybody around. What happens to my 30? 75. Stay or go? -6. 25 plus 6. 75 minus 30. Good. Not October yet, right? Yeah. Wait until October, huh? Okay. Okay. Yeah. October's Halloween. Might have to look at the calendar. Okay. How to deal with a decimal. Decimals are even easier. Okay. Decimals are snap. If you can handle fractions, you can handle decimals in your sleep. Here's what's going to happen, guys. Watch. Okay. It's not bad at all. Watch. You don't like the decimal? Well, in order to get rid of the decimal, we have to multiply by what? What will move a decimal point? A 10. Okay. If I have one decimal point to move, you're going to move it with a 10 because it's got 1 0. If I need to move 2 decimal points, I use a number with 2 zeros. Okay. The number of zeros is the number of decimal places it moves. Okay. So if I multiply something by 1,000, that's got 3 zeros, right? That'll move a decimal point 3 places. Okay. Every 0 moves a decimal place. And now, when you do that distribution, there's no work involved, guys. All you do is move a decimal point. You write the same number down with a decimal point moved over. So 2.1 becomes 21. 4.3 becomes 43. 6.4 becomes 64. And now you move everybody around, and you divide, and then you're done. Okay? What's 21 divided by 21? 1. I'm seeing way too many people telling me it's 0. Okay? Think about that. 21 times 1 is 21. 21 times 0 is 0. Okay? So you guys are confusing division and subtraction. All right? Anything divided by itself is 1. And in fact, we can write that step out. Okay? Don't tell me that that's 0. The only way you're going to get 0 is if you already have 0. Okay? Can't multiply and make 0 unless you already have 0. We all right? One more? How about? Actually, I'm going to make my life a little easier here, guys. And yours too. Make that a 1. All right. Well, if I used a 10, that would only move 1 decimal point, right? And that would be okay for the 3.1 and the 10.4. What are you going to use if you want to get the 1.12? You got to get 2 decimal places. Yeah, you're going to use 100 because 100 is going to move 2 places. And that's going to take care of this guy. Come on, we can do it that way. Because multiplying by 10, just a single 10, moves 1 decimal spot. But if you want 2 decimal spots, you got to use something with 2 zeros. So this is just going to move it over. What's it going to do here if it moves it 2 spaces over? What would it turn into? 310, right. And here would become, right. You see, it moved it 2 places. And by moving it 2 places, we had to put a 0 in there for a placeholder. Yeah. No, I'm doing 100. I got to do the same thing on both sides, right?
No, I realize that, but normally wouldn't you just use 10?
Oh, if that was the only thing I had to care about, yeah, I would only use a 10. But the biggest thing I got to worry about, yeah, the 1.12. This 1.12 has 2 decimal places to worry about?
I thought we were like moving this to the left.
No, because when you're multiplying by 10, it's getting bigger, right? So 1040 is bigger than 10.4. All right. Four minus 1 is 3. 10 minus 3 is 7. Okay, now we're subtracting. See what I did there? Subtracting them off. And yes, that does reduce. It reduces by a bunch. And we can probably reduce it by, at least by 2. And we're done. Yes, you will get weird fractions for your answers today, but what I want you to do on this sheet first is to work on the front page, because that one doesn't have any fractions or decimals on it. We'll see how far we can finish with that today. And if you want, you can start on the back with the fractions, but this whole thing is going to be classwork, and what we don't finish will become homework. Okay? So if we can try and finish, by the end of the day, we won't have homework over the weekend. Yes, the whole thing. Front and back, and the word problems as well. This episode of the by the least common multiple.